Hey folks, Ms. Gosling here with yet another video on solving momentum and impulse problems. In this video, we are going to be using force time graphs to solve our problems. So, without further ado, let's go ahead and get started. A 2-kilogram cart has an initial velocity of 0 meters per second. Using the force time graph to the right, determine the cart's final velocity. So, to do that, there are a couple things that you need to know. First of all, the area under a force time graph is equal to your impulse, which of course is equal to your change in momentum. And we can always break up the area of our graphs the way we always have by turning them into shapes that it's easy to find the area of. So let's go ahead and try this out. I'm going to start by listing out my givens. So my givens are the mass of the cart is 2 kilograms, and the initial is equal to 0 meters per second. My unknown, moving forward, is the final velocity of the cart, because we know its mass is not going to change. So the equation that relates these is that our impulse is equal to our change in momentum, which is equal to P final minus P initial. We're also going to need to know the equation impulse equals, this isn't really an equation, but we need to know that impulse equals area under force time graph. So I'm going to go ahead and I'm going to move to what I'm going to call my substitution step. But before I do anything with putting in numbers or anything like that, I'm going to go ahead, find the area under my graph. And to do that, I'm going to start by just erasing some of what I'd already drawn in there so that it's a little less busy. So I'm going to go ahead and I'm going to start here with this triangle. Then I'm going to go forward to our big rectangle in the middle, then to our smaller triangle over on the right, and finally this straight line. So let's go ahead and do that. So area 1 is going to equal 1/2 base times height, or 1/2 time times force, which is equal to 1/2 times 2 times 2. So our base is 2, our height is 2, and that is going to give me an area of 2. Now we can go forward to our next section, area 2, and that is going to be given by just base times height, since we have a rectangle instead of a triangle. So our base is 3, and our height is still 2, so our area is going to be 6. And I'm going to actually go ahead and add in my units as well. So base is measured in seconds, our height is measured in newtons. So my area is in newton seconds, which, as you know, is the unit for impulse, and is also 1 unit for momentum. Let's go ahead and do a 3 now. So my third area, again, is 1/2 base times height, since it's a triangle. Our base this time is 3, and our height is still 2. So that's going to give us an area of 3 newton seconds. And finally, we have our fourth and final area, which is just a straight line. I'm going to go ahead and use base times height. It doesn't really matter which equation I choose, though, because while my base is 2 seconds, my height is 0, so my area is 0 newton seconds. So I can go ahead and find my total impulse. So J equals A1 plus A2 plus A3 plus A4. So my total impulse is going to be 2 plus 6 plus 3 plus 0, which is going to give me a total of 11 newton seconds. So now I am ready for my substitution step. I know this is a lot in the middle, but you guys can do this. You've done this plenty of times before with our regular motion graphs. Let's go ahead and substitute in. So my impulse is 11 Newton seconds. My final momentum is given by my mass, which is 2 kilograms, times my final velocity, which is my unknown. So it's going to go ahead and stay as a variable. And from that, I'm going to subtract my initial momentum, which is going to be 2 times 0. So again, my initial mass, which is still 2 kilograms, my mass hasn't changed, times my initial velocity, which is 0 meters per second. And what's really nice is this whole term is going to cancel out because anything times 0 is equal to 0. So, simplifying that, we get 11 is equal to 2 times my final velocity. And finishing out and solving, I'm going to go ahead and divide both sides by 2. So 11 over 2 is equal to 2v final. Again, dividing both sides by 2. That gives me v final is equal to 11 halves, or 5.5 meters per second. And there you have it, folks. Now you know how to use force time graphs to figure out your impulse and use that impulse to determine your change in momentum and therefore your final velocity. So at this point, you should have everything you know to solve problems on your own. Go ahead and give it a try. Happy solving!